going to talk about today is the product property. And it says if I have two numbers being multiplied under one square root, I can split that up into several square roots. I can split that up into the square root of one number times the square root of another number. And this is useful because if I get a square root that I can't take the square root of, like for example 56 is not a perfect square, right? You should check that, unless you believe me. Do you believe me?
I believe you.
You believe me? Okay, good. So 56 is not a perfect square. If you try to type this in the calculator right now, you get one of those really long decimals, right? It's an irrational number. But if I know how to factor 56, I can split it into two numbers so that one of the numbers is a perfect square, and I can take a square root of part of it and leave the rest inside. So let me show you how that goes.
Wait, I almost copied. Okay, I got it. I got the, like, I needed the top sentence still, parts of the top sentence. Are both.
So the first thing I would do is I would factor 56. So the way I'm going to show you on the first couple of problems is what I would call the long way. It's a way that works every single time. And then I'm going to tell you how I would do it, which is much quicker, but requires more thought. Okay? Oh, thank you. Let me plug this up. So you guys factor 56, although we did just factor it, so you should already have it.
Can you go back? Yeah, go back. The factors 56 are 2, 2, 2, and 7.
Good. Okay, so if we factor it, we did it a minute ago, I'll do it again, so it's on video, but we get, stop, there we go, 2 times 28, 2 times 14, 2 times 7, 7's prime. So I could rewrite this as the square root of so I rewrote the square root, so then instead of having 56 under there, I've got its prime factors underneath. What I can do is, anytime I have a pair of the same factors, for example, a 2 and a 2, I can actually pull that out. Because here's what's really going on here. I'm going to start this board. 2 times 2 is what?
4.
And 2 times 7 is what?
14.
So I could rewrite that as the square root of 4 times 14. Okay? And then this property that I've got says if I've got the square root of some number times another number, I can split that up into two separate square roots. So I can think of this as the square root of 4 times the square root of 14. Well, the square root of 14 I can't take. But the square root of 4 is what?
2.
So this square root of 4 just becomes a 2. The square root of 14 stays where it is. And I get 2 times the square root of 14. That's the simplified version of the square root of 56. And I want you to confirm for yourself that the square root of 56 and 2 times the square root of 14 are the same, and here's how you'll do that. Type the square root of 56 in your calculator. Everybody should do this. Type it in, square root of 56, hit enter. Don't clear your screen. Leave that number sitting on the screen.
Wait, what do we do? 56 square root of 56?
Square root of 56. So you got that number sitting there. Now type 2, then the square root button 14, so you're doing 2 times the square root of 14, and hit enter. And you should get the exact same decimal you got before.
Wait, you just do the first set.
So they have the same value. Square root of 56 and 2 times the square root of 14 have the exact same value. They are the same number. Yes?
What's the point in making that rule if you can just click the square root and get the square root of it?
Okay, because sometimes I want to be able to simplify expressions, radical expressions, and I can't simplify them unless I'm able to do this. Okay? You'll see, as we get into some more advanced problems, you'll see the usefulness. So this whole factorization thing, when I realized that I can circle this pair of 2's, you'll see what happened. I pulled out the 2, 1, 2 for that pair, and I multiplied the stuff that was left over, 2 times 7 to get 14, and that's what stayed inside. Okay? So that is the way that works every time. I'm going to work a couple more. Does anybody need more time with this? Okay, so let's work a couple more. So the first thing I need to do on this one is factor 147. So I will make a factor ladder, and I need to figure out the smallest number that goes into 147. I know 2 doesn't go in there, it's not even. Does 3 go in there?
Yes, 49 times.
Okay, so 3 goes into 147 49 times.
7.
7 goes into 49 7 times, and 7 is prime. That means I can rewrite this as the square root of 3 times 7 times 7. Do I have a pair of the same number?
7.
So I will circle the 7, and that means I get to pull, let me write the answer over here. I get to pull the 7 out, and what stays inside?
3.
3, the thing I didn't circle.
That's it.
That's the answer.
Where did you get that thing? Why did you?
Which thing? This thing? So 147 equals 3 times 7 times 7. And so I rewrote it, right? So this way works every time. It's kind of a nice thing that it's not one of those you really have to think too much about it. As long as you can do this and you can recognize when you got a pair of things, this is easy, right? This works the same way every time. Now, some of you will be able quickly to do this in a faster way. For example, if I was factoring this, the minute I got 3 times 49, alarm bells start to go off in my head because I know that 49 is a perfect square. So I know that I would stop factoring at this point, and I would not ever write this. I would say, oh, well, 147 is 3 times 49. Okay, well, I know that the square root of 49 is 7, so I'll take that. And I can't do the square root of 3, so that's got to stay inside, right? So I'm skipping some steps. And on some problems, like, for example, number 3, I don't even factor, right? Because I can figure it out without having to. So we'll talk about that when we get to 3. Let's do 2. So I need to factor 605.
It goes in there 5 times.
5, okay. I know definitely 5 will go in there, and 5's prime, so I can start with that. 121 times.
11, and 11 goes to 11 more times.
And the only numbers that go into 121 are 11 and 11. So this equals, I got a pair of 11s.
11 square root of 5.
Very good. And you can say this, if you wanted to communicate this to me, like to tell me to write it on the board, you could say it as 11 times the square root of 5, or you can say 11 square root of 5. That's fine too, right? Okay, this problem, here's how I would do it. I know that 25 goes into 75. We all know that, right? 25 goes, and I know that 25 is a perfect square. So I would go straight from the problem to the answer, because I would say, okay, well, I know this is 25 times 3. So that means I can pull out a 5 for the square root of 25.
And another 5.
And I put back the 3. I don't get to pull out another 5. You just get to pull out 1. Because, look, did I pull out 2 11s?
Yeah.
I just pulled out 1, right? So I'll do it the long way and you'll see.
Yeah.
Okay? So 75. The smallest number that goes in is 3. 3 goes into 75 25 times. 25 is 5 times 5. 5 is prime. So that means this is the same as the square root of 3 times 5 times 5. And I've got a pair of 5s. So I get to pull out a 5. And I put back the 3. Okay? Questions about these?
Is this all we have to do, or is there a lot more to it?
There's more. I'm on 7 and 19, right?
Yeah, go.
But it's all this easy. The only thing that's kind of hard is dealing with conjugates, and that's at the very end. And we'll actually do that again tomorrow. So
At least we ain't
no
gonna
big.
do
Well, let's go ahead and jump with that. Since we can do
Well.
this.
Dude, I don't wanna come to math anymore.
All right, let me give y'all something to work in a clock appointment, unless there's questions about this.
I have every single question in the world.
Really?